Hello everyone. Today we are going to start with atoms and molecules chapter, which is chapter number 3 from your science textbook. This is the first chapter of your term 2, and in this chapter we will talk about the atoms, the basic philosophy of atom, from atom how you can form the molecules, how to write the molecular formula, what all the important things you have to remember from this chapter, and ultimately we will end up with mole concept. That a mole concept is a basic, or you can say the very important part of your grade 9, 10, 11, 12 syllabus for chemistry, because once you understand the mole concept you will understand a major part of the chemistry. But before starting with a mole concept and all, we have to start with a atom, and for atom you should understand the basic philosophy behind it. So here we go. The idea of divisibility of matter was considered long back in India around 500 BC. So you can see how old philosophy it is, like 500 BC, which is very old time. At that time, the first idea of this atom was given by Maharshi Kanath, and he said that the basic thing is nothing but the Parmanu. I hope you know the story behind it. In ancient time, there was the concept of Gurukul, where student used to go to Guru's place to gain the knowledge. So once upon a time, when Maharshi Kanath was sitting at his place, one of the student asked him, Guruji, please tell me, what is that one thing from which this universe is made up of? Then Maharshi Kanath asked him to bring one brick from nearby area, and as an obedient student, that student went to nearby area. He brought the brick, and then Maharshi Kanath asked him to break the brick now. He break the brick, and Maharshi Kanath asked him to do it again, again, and again. And one point came when that brick becomes completely in a powdered form. Now Maharshi Kanath told him that if you keep this powder at the tip of needle, and if you try to break that small particle from the tip of the needle 1,000 times, you will see this universe is made up from that small particle, which is nothing but the Parmanu. Okay, so that is one of the story which I heard from my childhood, so I just shared with you. After Maharshi Kanath, you can say the Pakuda Katyama also contributed to the philosophy. He said the particles normally exist in the combined form. And after that, after Indian philosophy, ancient Greek philosophy also contributed a lot in this philosophical aspect of the atom, that is Democritus and Leucippus. Democritus actually gave this word, the atom, means what? Indivisible. Yeah, atom is nothing but the thing which is indivisible. You can't break that one particle beyond the limit. So he gave the term atom. But the problem with this atoms theory is all this is just a philosophy, right? And there was no much experimental work was validated by then, and because of that you have to just say, okay, so this is the atom and everything is made up of atom. But by the end of 18th century, scientists recognized the difference between elements and compounds, and naturally becomes interested in finding out how and why elements combine and what happens when they combine. So after, you can say, at the end of 18th century, everyone was interested in this particular atom, how this atom is made up of, is it divisible or indivisible, and whatever philosophy we are having with us, is that true or not. Then very first scientist which we recognize, that's Antoine Lavoisier, laid the foundation of chemical sciences. And if you don't know, let me tell you, Antoine Lavoisier is also known as father of modern chemistry. So you can understand why he is very important for us as a scientist, right? So Antoine Lavoisier laid the foundation of chemical sciences by establishing two important laws, and you know which two laws we are going to talk about. First law is law of conservation of mass, and second is law of constant proportion. Yeah, so the way we say the law of conservation of energy, same way law of conservation of mass also we have a same definition. Like law of conservation of mass states that mass can neither be created nor be destroyed in chemical reaction. In a simple way, if you have reactant like methane and I have oxygen with it, and when the reaction will complete, you will get carbon dioxide and water. So if you know the masses of individual atoms, then you can calculate the overall mass of the molecule. We will learn about it. How to calculate that, we will learn. But right now, I'm directly telling you how you have to check this law of conservation of mass. So methane is having mass 16 gram and oxygen is having mass 32 gram. But as you see, there are two molecules of oxygens are going to combine. That's why overall mass will be 80 gram. So on the product reactant side, you have mass equal to 80 gram, and when the reaction will complete, you will get carbon dioxide and two molecules of water on product side. So if you calculate the mass, overall mass on the product side, that is 44 gram of carbon dioxide and 18 into 2, that is your 36 gram of water. So if you combine this, the mass will become 80 gram. So basic idea behind this example is what? The mass of reactant will be equal to mass of product. So you have to remember that point. Now, based on that, we have to solve few questions. So let's start with the question number 1. I would request you to pause your video and try to answer this. Okay, so I hope you have done with that, and we are going to solve this. A chemical reaction is balanced when both sides have same elements, both sides have same number of atoms, same subscripts, or same coefficients. What do you think? Both sides have same elements. Okay, that doesn't make much sense to our question, because in the previous example, both sides were having same elements, but number was not same. So both sides have same number of atoms. That will make your answer perfect. That is the answer for your question. That is, both sides have same number of atoms. And when you have a same number of atoms on both sides, that will make the law of conservation of mass correct. Okay, that will prove the law of conservation of mass here. If reaction starts with a 20 gram of reactants, it should produce. So again, please pause the video and answer this question. So you have given 20 gram of reactants. So what you are expecting on the product side? Option A is given a total 40 gram of products. Okay. The total 10 gram of products, total 80 gram of product, or total 20 gram of product. Obviously, answer will be option D, that is total 20 gram of product, because mass of reactant equal to mass of product. You have to remember this particular formula. So after law of conservation of mass, which is very easy to understand, we should start with the next law, that is law of constant proportions. This law states what? Many compounds were composed of two or more elements, and each such compound had the same elements in same proportion, irrespective of where the compound came from or who prepared it. For example, if you talk about the water, okay, so water composed of formula H2O. Now doesn't matter how I get this water. I got this water from river, I get this water from India, I get this water from maybe America, doesn't matter. Your hydrogen and oxygen will combine in a fixed ratio of their masses. As I told you previously, we will learn about it. What is the mass of hydrogen, what is the mass of oxygen, but for time being, let me tell you that hydrogen is having mass 1, but as you have two more atoms of hydrogen, so we have to multiply by 2, is 2. What is the mass of one oxygen? Mass of oxygen is 16, right? So if you try to take a ratio of hydrogen is to oxygen, then you will find out that the ratio will become 1 is to 8. It means that doesn't matter from where you get the water, every time ratio of hydrogen is to oxygen will be 1 is to 8 in case of water. Okay, here we are just talking about water as an example. So I hope you are clear why the ratio of hydrogen is to oxygen is 1 is to 8 in case of water. And this ratio is of what, guys? This is the ratio of the masses, the ratio of mass of hydrogen to the mass of oxygen. I hope you are clear with this example. So if you are clear with the previous example, I request you to read the question, pause the video, okay, and then answer in the chat if you want to. So let's start with the question. What is the ratio of elements of following compounds? That is NH3, that is ammonia. Okay. For ammonia, nitrogen is there, which is having mass equal to 14. Yeah, and hydrogen is having mass equal to 1. Okay. Now please try to get a ratio of nitrogen is to hydrogen here. So nitrogen is having only one atom in ammonia, so 14 multiplied by 1 is 2. Hydrogen is having mass 1, but there are 3 atoms of hydrogen, that's why I will multiply with 3. So if you try to take a ratio, so 14 is to 3. I don't think you can divide it further, and that's why you have to stop here, and that will be your final answer. And if you see the options, option 1, 2, 3, 4, your answer will be option number 4. So ratio of nitrogen is to hydrogen is nothing but the 14 is to 3. I hope all of you got the same answer. Okay. So thank you guys. We are going to stop here, and I hope you got some idea about the two laws of conservation, law of conservation of mass and law of constant proportion here. We will start with the Dalton's theory in next video. Till then, please make sure you will revise this topic and you will solve some more questions from your book. If you like the video, please make sure you will uh, press that like button as well, and you will subscribe to the channel as well. Thank you everyone. Thanks for joining.